Hello everyone, welcome back to my YouTube channel. Myself Grishma, I am pursuing my BE in Sri Venkateswara College of Engineering. Today's course title is Mathematics, course code BMATS201. Topic Stokes Theorem and its applications. Introduction to Stokes Theorem. In this presentation, we will explore the applications of Stokes Theorem in vector calculus. Stokes Theorem relates a surface integral over a surface to a line integral around its boundary. We will delve into its significance in various fields such as physics and engineering. Topics that we are going to learn in this PPT are history about Stokes Theorem, definition of Stokes Theorem, mathematical expression, proof of theorem, physical significance, practical applications of Stokes Theorem. Stokes Theorem. The theorem is named after the Irish mathematical physicist Sir George Stokes, 1819 to 1903. What we call Stokes Theorem was actually discovered by the Scottish physicist Sir William Thomson, also known as Lord Kelvin. Introduction to Stokes Theorem. Stokes Theorem is a fundamental result in vector calculus that relates a surface integral of a vector field to a line integral of the same vector field along the boundary of surface. It is named after the Irish mathematician Sir George Stokes. Stokes Theorem is a higher dimensional generalization of Green's theorem which relates line integrals to double integrals. Statement of Stokes Theorem. Stokes Theorem states that the surface integral of the curl of vector field over a closed surface is equal to the line integral of the vector field along the boundary of the surface. Mathematically, it can be written as integral curl f is into ds equals integral f dr, where f is a vector field, ds is the differential surface element, and dr is the differential line element. Stokes theorem can be expressed in both differential form and integral form. Mathematical expression. Integral from C vector A into dr is equals to integral del operator into vector A into d vector ds. Stokes theorem thus converts surface integral into line integral over any path which constitutes the boundary of the surface. Where inverted triangle is known as del operator, it is given by del operator equals vector I dou divided by dou x plus vector j dou divided by dou y plus vector k dou divided by dou z. It is treated as a vector in Cartesian coordinate system, but it has no meaning unless it is operated on a scalar or vector. Proof of theorem. In order to prove this theorem, we consider that surface S is divided into infinitely small surface element delta S1, delta S2, delta S3, etc. having boundaries C1, C2, C3, etc. Boundary of each element is traced out anti-clockwise. The line integral of a vector field vector A round the boundary of a unit area in xy plane is equal to the component of curl vector A along positive z direction. Thus, the line integral of a vector field vector A along the boundary of surface is equal to the product of curl vector A and normal component of area delta Si. A similar process is applied to the surface element, tracing them all in the same sense. Then above equation holds good for each surface element, and if we add all such equation, we have summation of I equals 1 integral vector A into vector dr is equals to summation of I is to 1 to n del operator into vector A into k delta s. Then all the integrals within the interior of surface cancel because the two integrals are in opposite direction along the common side between two adjacent area elements. The only portions of the line integral that are left are those along the sides which lie on the boundary C. The equation can be written as summation of I equals 1 n del operator into vector A into k delta s, which is equal to integral del operator into vector a into k ds, where n is infinity, si is 0. Hence the equation 1 reduces to vector a into dr integral del operator into vector a into k ds. This is Stokes' theorem for a plane surface. Physical significance. If integral vector a into dl is equals to 0 for any closed path, then a is called irrotational or conservative field. If a denotes the force, then integral f into dr equals 0 means the total work done by the force in taking a body around a closed curve is 0, that is, total energy remains conserved throughout the motion. Practical applications. It is used for determining whether a vector field is conservative or not. It allows one to interrupt the curl of vector field as measure of swirling about an axis. Exploring the applications of Stokes' theorem. First one, application in electromagnetism. Stokes' theorem is extensively used in electromagnetism to relate the circulation of the electric field around a closed loop to the rate of change of magnetic field through the surface enclosed by the loop. It is a crucial tool in understanding Maxwell's equation, which describe the behavior of electric and magnetic fields in space. By applying Stokes' theorem, one can simplify the calculation involved in solving the complex electromagnetic problems. Application in fluid dynamics. In fluid dynamics, Stokes' theorem is employed to study the circulation of fluid flow around a closed loop and its relationship to a vorticity within the fluid. It allows researchers to analyze the behavior of fluids in various scenarios such as turbulence and boundary layers flows. Stokes' theorem provides a mathematical framework for understanding the dynamic of fluid motion and turbulence. Application in mathematical physics. In mathematical physics, Stokes' theorem is applied to study various physical phenomena such as fluid flow, heat transfer, and wave propagation. It helps in analyzing the flow of energy, momentum, and other physical quantities in different systems. Stokes' theorem provides a powerful tool for modeling and simulating complex physical processes in mathematical framework. Fluid dynamics and Stokes' theorem. In the context of fluid dynamics, Stokes' theorem allows us to relate the circulation of velocity field around a closed path to a flux of vorticity through the enclosed surface. This is fundamental in understanding fluid flow and turbulence. Computational modeling and simulation. Stokes' theorem in integral in the realm of computational modeling and simulation. It enables accurate calculation of flux and circulation, facilitating the development of numerical methods for solving complex physical problems. Engineering application. Engineers utilize Stokes' theorem in various applications such as structural analysis, heat transfer, and material science. It provides a powerful tool for analyzing the behavior of vector fields in complex systems and designs. Interdisciplinary significance. The interdisciplinary significance of Stokes' theorem extends to fields such as geophysics, biophysics, and geometric modeling. Its applications are diverse and continue to evolve in the pursuit of knowledge and innovation. Thank you for watching my video. Please do like, share, and subscribe.